Question number 2A is graphing an inequality. The inequality that we're graphing in this one is a linear inequality. I think we need to do a little better job of recognizing what type of inequality that we're given. This is linear. There's no absolute value. There's no squared. There's no greatest integer function. Each of these are raised to the first power, and there's no multiplication. There's no division of variables. This is linear. And if it's a linear equation, then we can solve a linear equation or graph a linear equation by, again, finding 2 points around the line. What I also want you to recognize is that this equation of this line is not in slope-intercept form. This one is not in the y equals mx plus b form. If it were, I'd probably graph a little bit differently. So I either get it to this form, or if I don't have it in that form, I use a different technique. And that's what I'm going to use on this one. The 2x minus 3y is greater than 6. This is really in our standard form. And in standard form, it's probably a little bit easier to graph a line by using your x and y intercepts. So what we're going to do is we're going to create a t-chart in this. And we're going to graph this line by looking at your x and your y intercepts. So what we do is we put in a 0 for x. If I put in a 0x, I'm going to find the y-intercept. Then I'm going to put in a 0 in for y, and if I do that, then I'm going to find the x-intercept. So now it's a matter of plugging in some numbers and seeing what our results are. So the first I'm going to put in a 0 for x, so it's going to be 2 times 0 minus 3y, and I can disregard the inequality just a little bit because I'll graph that and just make it equality. It makes it a little bit easier. So 2 times 0 is 0, and that's a negative 3y equals a 6, which means y has to equal a negative 2. So my y-intercept is 0, negative 2. Then I want to do the same thing, only this time I want to put in a 0 for y. So I'm going to rewrite the equation up here. It's going to be 2 times x minus 3 times an input of 0 for y is going to give me a 6, which means 2x has to equal a 6, which means x is equal to 3, which tells me the y-intercept is the ordered pair 3, 0. So now I'm going to graph those ordered pairs. So 0, negative 2, that's my y-intercept. And 3, 0, that's my x-intercept. And now I'm going to connect those with a dashed line. The reason it's going to be dashed is because it's just a greater than sign. So I'm going to grab just a dashed line here that I can make it a little bit straighter. So there's the boundary line, and on that boundary line is where all of our values are exactly equal to 6. We don't want it to be exactly equal to 6. We want it to be greater than 6. So what we do is we test a point on either side, and we said one of the easiest points to select is the ordered pair 0, 0, or the origin. As long as our line doesn't pass through it, that's a very good candidate to throw in for your x and y value. So this is an x, and that's a y value. We're going to plug it into our original equation. So I'm going to have 2 times 0 minus 3 times 0, and is that greater than 6? I'm going to evaluate if that statement is true or false. So that's a 0 minus 0, is that greater than 6? Is 0 greater than 6? And because 0 is not greater than 6, this side of the line gives us false statements, but we only want to know whether our values are true. So that is on the bottom side. So I can either shade or just put arrows down there. But that's how I graph a linear equation when it's not in slope-intercept form. Put in your x and your y intercepts. Now, there were a few of you that tried to put it in slope-intercept form, which works perfectly well. I'll try to illustrate that quickly here. You can take your equation 2x minus 3y is greater than 6, and you can solve this for y. That means a negative 3y has to be greater than, I'm going to put a negative 2x plus 6. Then I got to divide by a negative 3, and if you divide by negative 3, it reverses your inequality sign. Negative divided by negative is positive, so it's a positive 2/3 x. And a positive divided by negative is a negative 2. So that's the equation that we're going to graph. This is the y-intercept. So I'm going to graph the y-intercept of negative 2, which is where we were before. Now I'm going to use the slope to get some more points, or at least one more point. Slope is always the change in the y's over the change in the x's. So I need to do a change of positive 2 and a positive 3. So from this point I go up 1, 2, I go right, 1, 2, 3. You can see I'm outlining the same line that we had before. Now we're going to put in our ordered pairs. So I want to put in the origin again, 0, 0. So I'm going to put in a 0 for y. So if I put in a 0 for y and a 0 for x, it's going to be, I'm going to use this equation to show you it doesn't matter. So 0 for the y has to be less than 2/3 times 0 minus 2. And is 0 less than a negative 2? and 0 is not less than a -2, so that's a false statement, so we want to be shading on the bottom side again. So either method that you choose will work just fine. Pick the method that's most comfortable for you. I think it's good to have some flexibility to be able to do both.